Today we are going to be talking about the Pythagorean theorem. The Pythagorean theorem states that in a right triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. When we think about a right triangle, we need to remember that that right triangle means that I have a 90-degree angle as one of my corners. The hypotenuse, or the diagonal side, or the longest side, the hypotenuse is always the longest side, is equal to the sum of the two legs, the two shorter sides. Those two shorter sides meet at a 90-degree angle, meaning the hypotenuse is opposite that 90-degree angle. So let's look at it. We're going to start with a line segment. In that line segment, we're going to add a semicircle. And the reason we're adding that semicircle is so that we can use this point to help us make our triangle. I'm going to go ahead and hide our arc. As you can see, I now have 3 points to make my triangle. This triangle, we said, has to be a right triangle, so I must have a 90-degree angle inside that right triangle. No matter how I curve this, that angle is always 90 degrees, meaning this one must be the hypotenuse, and each of these is a leg of our right triangle. Now the theorem says that it is equal to the sum of the squares of each of these sides. So when we think about the squares, that's a squared would be a times a, b squared would be b times b. And so to do that, we use a visual representation of our squares. So a and a, meaning we have a squared plus b squared equals c squared. The area of these squares is equal to the length of each leg times itself. No matter how I move this, okay, as I grow, the leg gets longer or shorter, the area of our square gets bigger and smaller. As a grows, a squared gets bigger. And the same with b. As I shrink it, the area of its square. Now C works slightly differently. I'm not moving C as I move and make A and B bigger. I can shift it and shrink it in and out to change the area of our C. Okay? Because our hypotenuse didn't change lengths. Our legs changed lengths originally. Now, when we think back to our theorem, it says that a squared plus b squared, so a squared plus b squared is equal to c squared. This works for all right triangles. The area, or the length squared, plus the leg b squared is going to equal c squared for every right triangle. And the really nice thing is using this formula, I can find a missing leg if I have both the hypotenuse and another leg. I can find the hypotenuse of our triangle if I have both legs. And so on every right triangle, we can use this formula, but it only works on our right triangles. So remember that it is the hypotenuse is equal, the square of the hypotenuse is equal to the sum of the square of the legs. So a squared plus b squared equals c squared.